Okay, let's look at this question now. Okay, there isn't much sentence in this question, but let me just put each sentence into a new line so that it's easier for us to read and convert them into the programming step later on. Okay, so these are the information given for this question in the consolidation quiz. Because of the copy paste, this square wasn't copy paste properly, the power, so I will just update that so that I won't mistaken the meaning when I was looking at the program, when I was looking into how to write the program. So this is also power 2, this is power 2. Okay, so let's look at the information given here sentence by sentence, and then we will base on that to figure out what are the steps. And the question seems to be too short, so we can expect it's very likely that the programming step given here is very short. We will need to expand it by ourselves. So a manual analysis is required. Okay, so let's see what the first sentence says. A number n is considered to be a steady p number if n to the power of p ends in the same digits. So an example is given after that. When n is 25, is a steady 2 number because 25 square is equals to 125. So 25 is 2 digit, therefore the last 2 digit of the square result is 25 also. So this is what it means by a steady 2 number. Okay, so seems like easy to understand. Another example is given as well. If n is equals to 376, then 376 square will give us the result of 141376, which 376 is 3 digit, and the last 3 digit here is 376 also. So this is also a steady 2 number. So looks like the first sentence here just define what is a steady p number. So it doesn't really contains any programming step, but if you want to keep this as a documentation so that when we come back to look at this M file in the future, you have information here to remind you what is steady p number. So why not? So we just leave it here as a general information. So these are the 2 examples which we could probably make it useful later on when we do the manual analysis. So let's see what is the next sentence. The next sentence says, determine how many steady 2 number exist in the range of n equals to 1 to 5,000. Okay, so this is a programming step. We can put it as a step, and the remaining ones is just more example. It tells us that the first steady 2 number is n equals to 1, and the range given to us also n starts with 1, so this is covered over here. And the second steady 2 number is n equals to 5. Okay, so we have 4 examples here. The last sentence says, you may want to use the num2string function. So this is a requirement, a suggestion. So it might be useful for us to write the program for this step. Okay, so obviously with this single line sentence is not enough for us to identify what are the steps required. So we will need to figure it out by ourselves, and a manual analysis is very likely to be useful. Okay, we need to determine how many steady 2 numbers exist in this range. So that means we need to run through all the value in this range. So that tells us that we need a loop for sure. And we need to then identify, do I need a for loop or a while loop in this case? So the range of n is given to me, and it is fixed to 1 to 5,000. So it is a fixed range. So we then know that for loop is a more suitable option because we don't see any condition involved here. Okay, so we wouldn't choose a while loop in this case. So n supposed to go from 1 to 5,000. Okay, so this will be the structure of the loop that we required. So since we have covered this in the structure of the loop, so we just remove this part. We will keep this as the comment. We need to determine how many steady 2 number. I will need to calculate n to the power of 2, n square, and after that I need to check whether it is a steady 2 number. Okay, so we are going to determine how many of these steady 2 numbers is in the range. So that means if yes, if it is a steady 2 number, then we need to count it. Okay, looks like what we need to do is something like this. So to help us to see how exactly we can write the code, let's try to do the manual analysis. We can make use of the example that is already given to us and draft a table to help us to see what is the pattern that happens in every iteration of this for loop. So we can see in this for loop, we have already identified that the control variable will have the range of 1 to 5,000. So n is the control variable. So let's start with that. Okay, so n will be the first column that I put in my manual analysis and see what else I need later on. So the first value of n is 1. So let's try to do this 2-step manually and see what else we need. Okay, so in order to determine it is a steady 2 number or not, I need to calculate the n square value. So that means I need to calculate n power 2. Okay, so for 1, the square of 1 is 1. Okay, so this part is fine. So is this 1 a steady 2 number? Because this n is 1 digit, so I will check the last digit. So this is a steady 2 number. What I'm checking here is it a steady 2 number? So that is what I would like to check. So I will document that in my analysis, and I will see that yes, this is the steady 2 number. Okay, so let's try another example, okay, which is n equals to 5, because that is what given in the example. So we make use of them first. We can insert more in between later on to help us to understand better. That is not a problem. Okay, so if n is equals to 5, then n square will be 5 square. That would be equals to 25. Because n is 1 digit, so I will check only the last digit, and then both are 5. So okay, it is a yes. Now we can see here that based on what I have been saying just now in these 2 iterations, looks like there is something in between this column of n2 and this is steady 2 column. So let's try to document that, because I mentioned just now that if n is 1 digit, then we will check the last digit. Okay, so that means I need to know how many digit is the value of n. Okay, so we just move this a bit further first, and this how many digit here is for n. So let me just put that information over here. So when n is 1, then it's only 1 digit. Okay, when n is 5, is also only 1 digit. So if n is 1 digit, then another thing that I have mentioned just now is that we will check the last digit of n squared. Okay, so the comparison that we will be doing in this case will involve the last digit, right? And this comparison is actually based on n squared. So I just keep that in my documentation. So it will be same for the second example when n is equals to 5. So let's try to put in more example and see if we need to expand into more columns. Okay, so these 2 example is done. What is the next value? Is n equals to 25. Okay, so I will try to put that into my table. N equals to 25, then n squared will be 625. Okay, it's supposed to be 625 here. So now the number of digit of n for 25 is 2 digit. Okay, so when it comes to doing the comparison, then I will need to compare the last 2 digits of n squared. Okay, and of course this one, I will get that it is a steady 2 number as well. And we just put in the other example also, which is n equals to 376. So when n equals to 376, the result of the square of it is 141,376. So we can document it over here. Now 376 is 3 digit, so it will be 3 digit, and we are going to then compare the last 3 digit. Okay, so which is this last 3 digit, and we can see that okay, this 3 digit is the same as the last 3 digit. Therefore, it is also a steady 2 number. So we can try with something that will give us a no to see if this format that I have developed also satisfied numbers that is not a steady 2 number, because we need a general one. So let's say I just try with 10. Okay, so n squared will be 100. So the value 10 has 2 digits. Okay, so in that case, I will need to compare the last 2 digits of the result, which is this last 2 digits. So I can see that this is 10, this last 2 digits is 00. So is it a steady 2 number? It is a no. Okay, so it looks like if it is not a steady 2 number, this table still able to give me the analysis correctly. So we can now start to write the code, okay, and try to generate all these columns inside our for loop. Or we will see also, as we write the code, we will also identify, do we need to initialize any of these value. Okay, n is the for loop control variable, so I don't need to create it inside the for loop or outside the for loop anymore. It's already settled. So in the next line of the code, I need to calculate n squared. Let me just put it here first, and we will see what else we need to do about it. I need to get the number of digit for n. Okay, so if I want to get the number of digit for n, so I cannot do it at the number level, because as a number, this 32 is just a number. So I won't be able to count how many digits it is. I can only do that if it is a string. So now it makes sense why the question gives us a hint that we need to use the num2string function. So if we convert this number to a string, it will become a vector of characters. So we can count how many characters are there, which will tells me how many digits does it have. So I need to know the digit of n. So which means I will need to make n becomes a string. So I will create a variable to store the string of n, and I also need to compare the last few digits of n squared. So I need that to be in the string format as well. So I will name the variable strn, which is a string version of n. It is equals to num2string n. Okay, and I also need the string version of n squared. I just name it str_n2, which is num2str n power 2. Okay, so in this case, this part is done. I will just put the comment here to remind myself that I'm converting n and n power 2 to string. Okay, next I need to get how many digits do I have in n. So now that n is converted to a string, so I can just use the variable digit to store how many digits do I have in the value n, which is based on the length of str_n. Since now I have converted the value n into string, which is a vector. So if n is 1, then length of strn will be 1. If n is 10, because it has 2 digits, when I convert to string, it will give me 2. So this way, I will be able to get the information for this digit column as well. Okay, so next we are going to look at the comparison. Okay, And if we discovered we need any more steps along the way, we will add it in. But for now, looks like the next column in my manual analysis is the comparison. So we will go into that. Okay, in order to do this comparison, I am comparing n as well as the last digit of n square. Okay, so that means I will need to look at how do I write the code. So in the if statement, I am comparing the string of n, and I want to know it is the same as the last few digits of n square or not. So we keep it like this first. Now we need to figure out how do we write the code for this part, because we need the last digit. I don't want to compare with the entire string. Okay, so now that strn2 is a vector, I can use array addressing to extract the last digit, which I can see from here that if I want to extract the last digit, I can use the keyword end. Okay, if you are not certain it works or not, we can test it in the command window. Okay, so let me clear the variables in my workspace. So I will set n equals to 1 now, so that I can test out this idea. So if I have n equals to 1 and I convert n to string, okay, so then I can also obtain the string for n square. So now let me try, do I get the last digit of this vector by putting end? Okay, so it gives me 1. It's fine. So what if n is equals to 5? Because this way I will actually have 2 digits. Okay, then I can try to run the same code again to see if it gives me the last digit, which is 5, because as we can see here, strn2 is supposed to be 25. So let me just run this. I get 5. So this idea seems to be working well. Okay, then under this condition is still end, so that is fine. Now, if it is a 2-digit value, then we need to extract the last 2 digit. Okay, so if the last digit is end, I need 2 digit means I need to specify what is the second last value. And if the last one is end, then the second last would be 1 value before end, so it is end minus 1. Okay, so let's test this also and see if it works. Okay, so I just change n to 10 and run these 2 lines of code. Okay, so now when I'm going to test with strn2, instead of end, I will put this end minus 1 to end here and see, does it help me to extract the last 2 digits of 100, which is 00. Okay, looks correct. So that means it works. And for the last two digit is fine. So how about if we need a last 3 digit? Okay, so this is the last digit is end. Second last is end minus 1. So the one before end minus 1, logically it should be end minus 2, isn't it? Until end. So again, we can just do a quick test in the command window to help us to confirm it is correct or not. Okay, so if I go from end minus 2 until end, so it should extract for me the last 3 digits, which is extracting the entire 100. Okay, so it looks like it's correct. So with this quick testing, it shows that this idea that I have developed over here, it seems to work. Okay, so the next thing that I need to look into is that if it is a single digit, it doesn't match with this pattern. So if I want all these to be inside the for loop, then they all must have the same pattern. So let me try and see, can I actually make this to have the same pattern as this as well? So by looking at these 2 columns, digit and comparison, I notice one thing. When my digit is 3, I will be -2. When my digit is 2, I will be -1. So it's always 1 less. So does it mean that if my digit is 1, I will be having END -0 until END. If this will also give me only the last digit, it matches the format with the rest of the iteration, then I don't need to deal with the single digit values separately. So let me try that. If I have END -0, it still give me the last digit. So looks like it's working fine. So now I can change this, replace END with END -0 until END. So in this case, I can see a common pattern for all the iterations. So I know that now, if I want to do this comparison, I will compare n, which is str_n, and the last few digits of n square. So I need to extract that last few digits by using this equation or by using this code. Okay, in this code, just now I have explored that this is always 1 less than the number of digits in n, so which is this variable digit. So that means this value, it should be digit -1. Okay, so that's what we see in these two columns. So if you are still not too certain, we can just test and see. So let me set n equals to 5. And I will run this entire code. Okay, then now I will try to make use of this to see if it extracts the last digit, which is 5. So, okay, with this testing, it shows me that everything works fine. That's good. So this if statement condition is done. So the if statement is here. And based on what we have documented, if yes, we would like to count that value. If no, the question didn't ask us to do anything as well, so we don't need to do anything. Therefore, the if statement structure, just like this, will be sufficient. We don't need the else section. Okay, so to count it, so perhaps we could just easily use the variable to count whenever it is yes. So which means if we just want to document it into the table as well, we can see that we need another variable count. Whenever it is yes, I will count 1. Okay, so whenever it is yes, I will count 1. When it is no, I won't do anything. So that tally with what this if structure do. And that should work as well if we try to study the manual analysis like this. Okay, so looks like fine, which means I can have count equals to count plus 1. So looking at this code inside the for loop, n is the control variable for the for loop, so I don't need to initialize it. So this line won't have any problem. This line don't have any problem. str_n is already calculated over here before this line, so this is fine also. When it comes to here, str_n already there. str_n2 is already there. END is a special keyword, so we don't need to calculate anything. Digit, we have it here, so not a problem. And this one, we have count plus 1. So in the first iteration of my for loop, I will need to initialize the variable count with something. So initialization happens before the for loop starts, isn't it? So before the for loop starts, we haven't do any counting yet. So the count will be logically 0 because we have not counted anything. Okay, so now looks like everything is covered. We have included this example as well, and we have used the num to string function. So let's just run this M file and see, does it generate any error? If yes, we will fix it. Okay, so I will just name this consolidation quiz question 5. Okay, so it runs, n runs up to 5,000, and the count is equal to 7. So it tells me that I have 7 steady 2 number from 1 to 5,000. Okay, just to make sure that I didn't mess up anything, I would add a line of CLC and clear so that every time I run this M file, it will delete all the existing variable in the workspace and start fresh. So from our analysis here, because the example just now told us the first steady 2 number is 1, the second steady 2 number is 5. So to test this code work or not, I can just do a quick test from 1 to 5, because 1 to 5, based on what we have done, we know for sure the steady 2 number count should be equals to 2. Okay, then we can check from here, is it 2? So let me run this and see if the count is equals to 2. So now when I run this, I see that count is equals to 2 and runs all the way up to 5. So that means the for loop did run 5 times. So everything seems to work correctly. So I will put 5,000 back. Okay, so that's how we can develop the program for this consolidation quiz question 5 based on the study that we got from the manual analysis.